Section 3.4, zero of polynomial functions. In this section, we want to discuss how to find the zeros or solution of polynomial functions. You know, we have discussed this. This is on page 273 of your textbook, and you either have the first degree polynomial like this one, x minus 2 equal to 0, which you have only one answer, or we deal with the second degree equation, the highest power of x is 2, and there are several ways to do that, either by factoring or quadratic equations. So in this case, you have these two answers, or the third degree equations. There is no formula for the third degree. So some of the third degree or higher exponent may not be that easy to solve unless we come up with some numbers, guess some numbers, and keep substituting those numbers into the equation to see if it works or not. Like, how do I know in equation of x minus 2 equals 0, how do I know x equal 2 is the answers? By taking that and substitute here, I see the result would be 2 minus 2 equal to 0. Or how do I know 3 is the answer to these equations? You take the 3 and substitute here for the x raised to the power of 2 multiplied by 6, and if the outcome is 0, that means x equal 3 is 0 of the function, or x equal 2 is 0 of this function. This is the rational 0 of the function. How would I come up with, guess some numbers to plug into the equations? It's possible rational 0 is factor of constant term. Every polynomial normally has a constant and leading coefficients. Like in this equation here, this example, constant is this number because there is no x in it. And the highest power of x is 3. So the number sitting next to x3, which in this case is 1, is your leading coefficients. So according to this, factors of constant term is how many factors are in 1? Just 1. And how many factors in 1? Just 1. So there's only two numbers, plus or minus 1, that you need to try. So when you substitute that, then you tell whether the final answer is 0 or not. And as you see, none of these two, if you use the syntactic or long division method, or when you substitute, it doesn't let the outcome equal to 0. So 1 and -1 are possible, but are not the 0. 0 is a number that is probably a very decimal numbers here. Okay. All right. Now, this is a better examples. The equation is this, x4 minus x3 plus x2 minus 3x minus 6. You take the constant, which in this case is -6. You find all the factors of 6, all the numbers that are multiple of 6. Means if you take a 6 and divide by all of these numbers, there is no 0. These are all positive, -1, positive, -2, 3, and 6. They all are factor of 6. So you write that. Then x to the power of 4, the number that you see in the front is 1. 1 is only one possibility, plus or minus 1. So all the possible factors for -6 is this, and for 1 is that. Then you take each of these numbers and divide. Since this is 1, all the possible numbers are positive, -1, positive, -2, positive, -3, means there are 2, 4, 6, 8 numbers that you need to try to see which one of these is solution to that equations. Normally, we start with the smallest number. So we try -1. We use the syntactic division. We fact all these here. -1 would make the remainder 0. So that means -1, x equal -1 is one of the answers. Then what is remaining here is this. So we list these numbers here. Now we try 2. Then we get another 0. Okay? So far, x equal -1 and x equal 2 are two answers. When x is -1, what is the parenthesis? X plus 1. When x is 2, what is the parenthesis? X minus 2. So you already take this and break it into x plus 1, x minus 2, and the remaining here is x2 plus 0, x plus 3. You write that here, okay? x2 plus 3, you cannot set it equal to 0 because it's just to give you a complex numbers. It doesn't give you a real number. You cannot find any number that when you reduce the power of 2 plus 3 equals 0. So basically, there are two real numbers here, 2 and negative 1. This is another example. Constant is 3. What are the factors of 3? Positive, negative 1, positive, negative 3. Leading coefficient, see the highest degree of x is 3. What number is sitting next to it? 2. What are the factors of 2? Positive, negative 1, positive, negative 2. Then you take each of these and divide by that. Like 1 divided by 1, 3 divided by 1. And then 1 divided by 2, 3 divided by 2. These are all the possibles. So you take 1 and divide by these 2, then you take 3 and divide by those 2. These are all the possible ones. Normally we use the small one, which is 1. In this case, 1 would make the remainder 0. So that would break this into a smaller equation. See, you put the x2 here, x here, and this is a constant. And then you could use the quadratic formula or factoring method and break it into 2. Constant is minus 12. So there are so many possibilities. Look, 1, 2, 3, 4, 6. These are plus or minus, of course. So there are 1, 2, 3, 4, 5, 6 times 2, 12 possibilities for just 12 here. And you also have 10. What are all the factors of 10? 1, 2, 5, 10. Then you take each of these and divide by that. 1 divided by 1, 1 divided by 2, 1 divided by 5, 1 divided by 10, then 2 divided by 1, 2 divided by 2, 2 divided by 5, and so on. So there are so many possibilities here. But when I try 2, 2 would break it into a quadratic, and then you solve it. If one of the answers that we give in the problems, if the answer is a complex number, you always have to write a conjugate, which is a minus pi. For instance, here, find the fourth degree of polynomial. Real coefficients are x minus 1, x minus 1. So that would give you two parentheses, x plus 1, x plus 1. But there is also x equal 3i. X equal 3i is given. You always need to find a conjugate too, which is opposite. The same thing with the opposite sign. So minus 3i also is another number, see? And the reason is, it said for 4 degree. For 4 degree, you need to have 4 x's. 1, 2, 3, 4. See, that's why when you have a positive 3i, you all have to create minus 3i. Then you put all of them here, and then you multiply out. See, it gives you a 4 degree equations. Just like, if I give you two numbers, like x equal 1 and x equal minus 3, and I ask you to tell you, okay, these are the solution of equation, find the equation. What would you do is, you open two parentheses. This is 1 parenthesis x minus 1. This is minus 3. The second parenthesis is x plus 3. So when you multiply this out, that give you equations, okay? If we give you another number, let's say x equal 1, x equal negative 3, and x equal 5, then you have 3 equations, x minus 1, x plus 3, x minus 5, and you have to multiply all these to come up with the third degree equation, and so on. If one of these happen to be, let's say, this is another example, x equal 1, x equal minus 3, x equal 1 minus 2i. And we say the 4th degree. Anytime you see a complex number, you should create another one, which is 1 plus 2i. See, now there are two parentheses, x negative 1, x plus 3, x minus 1 plus 2i, x minus 1 minus 2i. See, you have to multiply all this. Okay, so that's what we're discussing here. And these examples, like here, look, one of the answer is 2. One is 1 minus 1, so you create 1 plus I. So there are 3, right? You put all 3 of them here, you multiply all out. The reason we put the A because we don't know what the coefficient is. But they're saying that and the final answer, when you put 1 for the x, y is 3. So when you put 1 for x, the whole thing is equal to 3. They do that so you could find your A, and then you put it back here. Another stuff that we want to discuss is, in fact, on the copy you have this one, but this is 281 with the upper and lower one. But let's just talk about finding a zero of the polynomial functions. One of the answer is given, 1 plus 3i. So the second answer is what? 1 minus 3i. So you write the equation and x minus 1 minus 3i, x minus 1 plus 3i. You put all these, that give you these equations. Now, you already have that one, and now you have this. When you take the whole functions and divide by this using the long division method, then you find the other piece. You understand that? Okay, so look, these 2 are given. So that gives you 2 parentheses. You multiply these 2 parentheses, and give you that. That is a part of the whole things. So like right now you have x4 minus 3x3 plus 6x2 plus 2x minus 60 is equal to this parenthesis times another parenthesis that you don't know. So that's why the long division method give me the second one. See, they give you the second parenthesis here, which is this. And then you break each of them to find all the answers. So we are using the long division method to find the second parenthesis here. These are other examples. You know, all the possibilities of 8 are given. Divide. What is Descartes' rules of the sign? You know, some of the problem, there are so many possibilities. To eliminate some of the possibilities, then you could use this law. Like example, it said if the number of positive real zero is either equal to the number of variations or less. For instance, here, you have this one. You know, there are all the possibilities are there. These are all the possibilities that you have to try, correct? But they are saying that variation here. Variation is, it goes from positive 3 to negative 1 variation from here, negative to positive 6, this is another variations, 6 to negative. There are 3 variations here. So possible positive answers are 3 or 1. Why is it 1? Because he said the number of positive real zero is either equal to number of variation, which in this case is 3, or less than by even number. It means all the there are 3 variations. So you either have 3 positive numbers or 3 minus 2, 1. So you either have 3 positive numbers or 1 positive numbers. Then you create one f of minus x, means you take minus x and substitute for the original one. You put, instead of x, you put minus x. In that case, if there is no variation, they all are negative. If they all are negative, then there is no variation in sign. Okay? That means the number of negative real zero of f either equal to the number of variation in sign less than. So this, in case you have all negative number, there is no variation, means you don't have to try any of the negative ones. All you do is just try the positive one. Why? Because when you put f of negative x, all signs are negative. There's no variations. So you see in these pictures, you do not go beyond negative. You don't go on the negative side of the x because all the answer has to be positive. No variations, no variation in the negative side. I'll put some example for you so you understand it. Right, this one, look at the variation. 1, 2, positive to negative, negative to positive, no variation here. Positive, negative, negative to positive. 1, 2, 3, 4 variation. So there are 4 sign change in the positive real zoo. This number 4 is the maximum possible number of zeros. So it's either 4 or minus even, which is 4 minus 2 is 2, 4 or 2. Now we also try negative x. When you try negative x, here you see there is a variation, only one variation here, okay? So that means there is one change in this negative root, so there is exactly one negative root. So you try just one negative root. You should come up with the one negative root. So you always try f of x and f of negative. F of x, you see there is one variations right here, only one. F of negative x, one variations, another variation. There are 2 variations. Same thing, f of x and 2. And then the last is, how do I find the upper and lower one? You know, some problem, there are so many possibilities, but sometimes we have to kind of cut some of this out so we don't have to try every single one. So in that case, in this case, we try f of negative x, all negative. So that means there is no negative answer. So eliminate all the negative one. Don't try any of the negative one because of this. Okay? But there is on the f of x, there is variation 1, 2, 3. So it's either 3 or, here it said, if c greater than 0, each number in the last row positive or 0, then upper boundary. So is this one, for according to the Decoder rule, you either have 3 or 1 answer. But we try 1. So you know all the answers. Okay, first we eliminate all the negative. So we know the answers, it could be 1, 1/2, 1/3, 1/6, 2/3, positive 2. But we try 1. 1 doesn't give me a remainder of 0. That means you cannot go beyond 1. 1 is your upper hand. Do not go beyond 1. Don't go beyond 1. So that would eliminate 2, or if there was another number 2, 3, 4, that's what upper is. Upper and lower, it cut all your answers. All the answers must be between lower and upper bound. So you don't have to go beyond that. So again, when I try 1, it doesn't give me a remainder of 0. That's the case, then see here, if a number is greater than 0, which in this case is 1, and each number in the last row is either positive or 0, then C is the upper boundary. Okay? So here, this shows that x equal 1 is not a 0 because the remainder is not, and that gives you the upper boundary. And when you substitute negative x, all of them are negative, means no variation in sign, means again, by Decoder's rule, there are 3 positive 0 and 1 positive, or 1 positive and no negative real 0. You don't have any negative 0. So you see on these pictures, the function never cut here means you don't have x equal negative number at all. Why? Because there was no variation of the negative. This is another example. This is a good example. I pick it from another textbook. There are so many possibilities for 48. So many numbers are factor of 48. So what we do is one of them is 1, 2, 3, 4, so on. We try a number like -4. Okay, see how it works. -4, it gives you a remainder. So that means there is a alternate. You see that alternate or variations? Sign alternative, that means -4 is the lower bound. See, if you pick a number which is less than 0, which in our case is -4, and the number in the last row are alternately positive and negative, then C is the lower bound. See, if you pick a negative number, and number on the last row are all positive and negative, then -4 is your lower bound. Then we try another number like 5. Everything become positive and no remainder. If that 5 is not a root. It's positive, right? So in that case, if C is greater than 0, which in this case is 5, and each number in the last row is either positive in our case, then C is the upper bound. See, all are positive, then C is 5 is upper bound. That means all the answers must be between -4 and 5. So that would eliminate so many trials. When you want to try all the possibilities of factors of 48, those numbers that are between 4 and 5, try those, but don't go beyond 5 and don't go below 4. All right. So now, this is the first degree. Obviously, the 0 is -C. This is the third degree. There are always, because highest degree shows you total possible numbers, answers 3. This is a second degree equation. Possible values are 2. These are all the possibilities. See, all the numbers of 63, you list all those here. All the possibilities of 2, the leading coefficient is 2. All the possibility of 2 is, each time you have to take one of these and divide by that. 63 divided by 1, 60 divided by 2, 21, 20, all the possibilities. When you try the first one, the -1, if you use the synthetic division, remainder is 0. So that would eliminate this to 3. I'll show it to you here. How to do that problems. So you find all the possibilities and then use a synthetic division, -1. -1 would give you a remainder of 0. So that would eliminate this to second degree, and then you factor second degree. You try -1, -1 give you 0. That would eliminate your third degree to the second. Synthetic divisions, you try -1. -1 will give you a remainder of 0. So that would eliminate the function into a quadratic that you solve. I did number 8 here because it's the long problems. See, these are all the possibilities. Look, 24 has all these factors. 9 has all these factors. You have to take each of these and divide. Look how many numbers you have. Normally, the very small one is a -2. We try that. That would give you a remainder of 0. So that would eliminate to this third degree. I use a group factoring here. If you remember that from algebra. Using the group factoring, that would eliminate to that. Then you have 3 answers, okay? For 8, 9, 9 is just, they're asking you, say, which one of this is correct based on the answer that they have. I think I have all this here. These are all the possibilities of 6. And coefficient is 1. So you try. The very first one, they give you a 0. See, sometimes, most of the time, that's the case. 1, 3, 6, positive, negative 1, positive, negative 3. When we try this one, they give you a 0. It's here, all the possibilities. (12, 13, 14), I have it here. Now, these are the problems that, remember, if we give you, this one is a graphing utility, but this is the one that when we tell you x is 1, like number 13, when you say x is 1 and x, the minute you see it, a complex number, you have to create another one, which is the opposite sign. So when you multiply all this, it gives you the original equations. Like here, these two are given, right? What is 2 plus I? What's the opposite of that? 2 minus I. You multiply all 3 of them to find your original equations. I go through all this because you have the solution. I'll go through it quick because you have the solution. I just want to show you that if you have 2, always create a complex conjugate, they call it. See, in this one, 2 real numbers and 1 complex were given, so you create a opposite or conjugate of this. So there are 4 of them. 1, 2, 3, 4 parentheses. You multiply all to find the original, to find the final equation. It's a lot of multiplications. (16, 17), I have it here. The function is given. You have to use the quadratic to break it or factoring. And it gives you all this. Again, this is use the group factoring. Use the group factoring. They all are very similar, 18. Now, when you multiply, it gives you that, right? See, number 18. Number 18 is the 3rd degree equations, right? Just one is given, one answer is given. Using that, x is minus 3 plus I, okay? So minus I, we have that. And then you write all the equations. So minus 3 plus I is given. Now we try minus 3 minus I. When you multiply these two, that gives you this part. So now to find, you use the long division, you take the whole polynomial, divide by that to find your other parentheses. To find your other parentheses, why? Because the remainder is 0. So 4x minus 1 is another one. How do we break this? That's how to do it. You know, formula of a minus b times a plus b is a2 minus b to power of 2. All the possible 5s, coefficient is 1. You try negative 1, it works, make it 0. So that gives you the equation. These are all very similar. And you have the solution for these. So if you use the Descartes' rule, they all are just one alternate, you know, go from positive to negative. This one sign variation is only 1. When you put a negative, They all are negative, so no negative variations, no negative zeros, because there is no variations. On this one also, f of x, g of x is one variation, g of x. G of negative x has also one variations. There is one positive real zero and one negative. See? And I'll give you another example here for the problems. It's 26. Number 26 here. This is the Shilluk solutions. We try one, and remainder is not zero, but they all are positive. If C is 1 and all the rows are positive, then 1 is the upper bound. We try another number, arbitrary number, like a -3. -3, remainder is not 0, okay? And this is for -3, I'm sorry. For -5, they alternate. See, when I tried -3, it didn't alternate, so that's no good. But for -5, it alternate. So when it's alternate, then we discussed that if C is less than 1, which in this case is -5, I'm trying to find that rule again. Look. If C is less than 0, like in our case is -5, and last row are alternatively positive or negative, then C is the lower bound, okay? Alternate, then C or -5 is the lower bound. All right, that was the end of this section.